So let's look at some best practices for Kirking. So the most important thing is that feature file should be well readable by the business, the product owner, in the language of the domain, and be as clear as possible. Everybody, that's the main part of behavior-driven development. Here you specify your examples. So here, for example, I say, given I click accept. That's not really clear, accept where or what. But if I say, given I clicked accept on the payment page, then it makes also for the product owner sense, okay, that I accept the payment. So be as clear as possible. Be careful for identical steps. So we see in this example here, given the user has $100 in his account, then the user has $100 in his account that has the same steps. So you get an error here. Independence. So this same best practices as we've seen with unit testing apply for all testing. So scenarios are independent from each other. Features are independent from each other. You are independent of the order of how you run scenarios. Similar as we've seen in test. Single responsibility. You want a given when then you want a scenario to test one thing. So you don't want here, for example, a procedure-driven test. So the idea is, given I open web browser and I navigate to google.com, when I enter Panda in the search bar, then links related to Panda is shown. When the user clicks on the image link, then images related to Panda are shown. And then when this happens, then this, when this, then this. That's sort of a procedure. First this, then this, then this, then this. You don't want that. Similar as in unit test. You don't do that. First do this, then assert this, then do this, assert this. No, it's one test per assertion, one assertion per test. So here, I check if I enter search in the Google homepage, but if I enter Panda in the search bar, then the Panda results page are shown. Another test, if the page of the results of Panda are shown, and you click on the image link, then all images related to Panda are shown. Single responsibility for test, similar as in unit tests. Each step does one action. So here you don't want, when the users enter user as username, password, or pass as password and clicks the login button. Then you say when the user enters user as username and enter pass as password and the user clicks the login button. One line, one step, one action. Don't put an action in the given. Given is a precondition, the when is an action. So there should be one action that's in the given, in the when. So here I say, given the user navigates to the Google homepage, well, you do already an action. So what you want is, given a web browser is at the Google homepage. So you don't do an action, that's the precondition. And in the when, you do something. You enter Panda in the search bar. So here's the action in the given step. Actually here there's also an action in the given step. So in the given, no action. No conditional logic. So we saw there is an and, there is no or in Kirking. Some people try the or and doesn't know about or. There's no conditional logic in a scenario. So here, for example, given a level is started from a game, when the player pushes the A button or the player pushes the B button, Mario jumps straight up. There's an or. This is not possible. Then Gherkin will complain, doesn't know that. So in this case, how would you do that? Given the level is started, when the player pushes the letter button, well, this is a scenario outline. I'll explain that after the best practices. Then this becomes clear. But this is basically a method with parameters, similar as we seen yesterday with fitness. So basically here you say letter is an parameter, an argument of the method. And then Mario jumps straight up. So we call it a scenario outline. And the scenario outline has always examples. And you can give it a name here, I call it buttons, but it's a table. So the first one is the letter of the name of the argument, in this case letter. So I say letter. And then we have all the letters available, A and B. So what will happen if I run this scenario? First, this one is called, given the level is started. Then, when the player pushes the A button, then Mario jumps straight up. And then starts again, given a level is started. When the player pushes the B button, then Mario jumps straight up. So similar as we saw yesterday with fitness, this is the way you do that in Gherkin. There will be an example from this. Push the data into the Java classes, the steps. So here, the scenario is user login. So given, and there's an action, basically it should be the user is in this is the ing.nl, that's a Dutch bank. The user is in this URL, and the user enters user as username and enters pass as password, and the user clicks the login button. Well, first of all, that should not all be in a given, it should be in a when. But anyway, let's say we have this. Then we are bound to, this test is bound to this URL, this username, this password, and then there should be a login button. Now what now if they change the URL? What now if the username or password changes? What if the login button is removed with a login link, a hyperlink, or it happens automatically, something like that? Then you have to change your test. So it's better to be more abstract. So given the user navigates to the bank homepage, whatever URL it is, the user enters a valid username, the user enters a valid password, the user logs on. It's very abstract. Now in your steps, you have to use this URL and you have to fill in the correct username and password. And maybe click on the login button. But it's in your steps. The scenario will remain the same if something changes on the web page, maybe the URL or the username or password. You only need to change the steps, but not the scenario. So keep the scenario abstract. It's a best practice. Then we're going to look at scenario outliner, and then we just saw an example. So what I said, a scenario outline is like a method in Gherkin. So what we did as an example, that's not very handy to do what we do here. So it's every time the scenario copy paste, and I change the numbers, and then I do subtract. I have many subtracts, and I do multiply, and I have many multiplies. That's a lot of copy paste, and then when something changes, you have to make a lot of changes. So what we want, these numbers, the 5 and the 25 and the 0 and maybe also the subtract and the multiply, we want to make a method where everything is always the same, only I make from these numbers and the action that you do, I make that an argument in a method. And that's basically a scenario outline. So here is given I have a calculator, and then this is only for add. I add num1 and num2, then the result should be total. So num1, num2 and total, and I can also use it here. These are arguments in a method. And then I have, so it's called scenario outline. It's not scenario, it's scenario outline. And a scenario outline always needs examples. These two go always together. This is basically the data for this method. And then I have num1, num2 total, so I put it in the first row, num1, num2 total, and then 2 plus 3 should be 5, 10 plus 15, 25, 9 plus 9 should be 18, 1 plus 10 should be 11. So now I have only one add method, but with a lot of data. I want to test 0 plus 0, and then I can run it. So this is my calculator with the add, and these are my steps. So I have a calculator, so here I add num1 and num2, looks like this. I add, and this is num1 and num2. And then here the result should be, so I assert that the result is outcome. That's how you use a scenario outline. So typically you want that. And I can also add another column where I make the add an argument, where I call it just I do and an operation. And I have a column operation where I say sometimes add and sometimes subtract, sometimes multiply. That would be even better. So here's another example. I have a parking lot calculator. Depending on how many hours you park, what is your subscription type? And there are subscription types. We have none, we have year, we have month, week, and 65 plus. You're a senior or something. And we have a discount option. And the discount option is in this case government. If you work for the government, you can park for free. So this is my algorithm here. Let's say you have a yearly subscription type, and if you park less or equal to 3 hours, it's free. If it's between 3 and 5, it costs $2.25. Between 5 and 8, $3.95, more than 8, then it's 3 times the hours divided by 8. That's my business rules that I want to test. So I can do this here. Given the user has parked for 3 hours, the user has no parking subscription, the user is not eligible for discount, the user wants to know how much has to be paid, the user need to pay $3.75. That's what I can do. But then I do a lot of copy paste. So this will work, but I do a lot of copy paste. And then here is my steps, and that should work. So with assert that I have to use the close to because it's in doubles, and here's the delta. Here's my class that I can run. This is what I have, and then everything is fine. Then I do copy paste and I say, okay, now it's 7 hours. You still have no subscription or discount, and it's $4.95. can run it, and everything should be okay. But better is to make a scenario outline. So I make hours an argument and the amount you need to pay. So here 0 hours did, 1 hour did, 2 hours did. So I make here a number of hours and then what you have to pay. That's already better. But I also need to test what if you do have a parking subscription? What if you do have discount? So I can do like this. The number of hours, the subscription type, the discount type, and the amount you have to pay. And I just filled in some data here. Typically you want to have more. That's better. And then you have here, the user has a subscription, that's one of these. The user gets discount, that's one of these. So that's always good to use, scenario outlines, data-driven tests.